Hello everyone. In this video, I would like to discuss the problem C of Codeforces round 857. In this problem, we need to build a matrix of size n cross m such that it is very beautiful. Now the condition for very beautiful is this. It is saying that if you choose any 4 cross 4 submatrix, then this condition should satisfy. It means that uh, every you can divide this 4 cross 4 matrix into 4 submatrices, then its jor will be 0. Like let's say you took this matrix submatrix, then you can divide it into 4 2 cross 2 matrices. Then this one, the jor of this all of these four numbers, four integers should be equal to this, and the jor of these four integers should be equal to jor of these four integers. If this condition is true for each 4 cross 4 matrix, so 4 cross 4 submatrices of n cross m matrix, then you will say that your n cross m matrix is very beautiful. Okay, so we need to build such a matrix, very beautiful matrix, such that the total number of distinct integers are maximized. So let us see how we can build such a submatrix. Okay, let us say our matrix is something like, initially let me put 0 everywhere in our matrix. Okay, so you can see that this matrix is very beautiful, because if you will take any 4 cross 4 matrix, then its diagonal matrices will have jor 0. So obviously this is very beautiful matrix. Now I would like to make distinct numbers maximum. So after some observations, it is seen that you can make all of the n cross m integers distinct, right? So how we can uh, go to this condition, like how we can make all of these integers distinct? You can see that if I add ith bit to the complete row, either to complete row or either to complete any column, then the matrix remains beautiful. How you can say that? Let us say I have made all of these, let's say the 0th bit, okay, leave it. Let's say I have set the second bit, okay, second bit to this complete row. So how will my new matrix look like? Okay, so second bit means 4, every position will be 4 4 4, and other guys will remain same. Okay, so you can see that if I choose any 4 cross 4 matrix, then it will be divided into 2 cross 2 matrix. Now each 2 cross 2 matrix will have jor 0. Okay, each 2 cross, if each 2 cross 2 matrix have jor 0, then you can say that our matrix is very beautiful. So here one important observation we have made is, if I set any bit to either row or either column, complete column, then our matrix remain very beautiful. Okay, so let us try to, from this observation, let us try to build our very beautiful matrix with all of the integers as distinct integers. So initially we will have 0 0 0, all of zeros in our matrix. Okay, and then we would like to make all of these rows distinct. Okay, first we will have each integers in each row same. Okay, and we would like to differentiate the rows. So how we can do so? First we will we will set first 0th bit in odd position. We will set 0th bit in this row, 1 2 3 4. First row we will set 0th bit in 0th bit in third row. Okay, so here we can see that first, third, 2 and second and fourth, these two row are different. Okay, now we would like to make these two row also distinct. So what we can do is we can set bit first bit to first row and leave as it is third row. So these two are also distinct. Okay, now we will set first bit to second row and leave as it is fourth row. So by doing this we are able to make all of these rows distinct. But now the problem is we have made all of these rows distinct, but the columns all of these rows distinct, pairwise distinct, but integers in this complete row are same. So we need to also make these integers in each row also distinct. So how we can do so? Similar to this construction we have applied on the rows, we can apply this construction on column also. What we will do? Okay, so what we will do? First, let's say our columns are 1 2 3 4 5 6 7 up to m. Now integers in each row are same in all of these columns, right? So we need to make these integers also distinct in each row. So what we will do is we will apply similar idea. Initially we will set 0th bit to all of these odd columns. Okay, so our columns are divided in two sets, 2 4 6, even numbered columns and odd numbered columns. These have same integers, these also have same integers, but these two are not same because these have 0th bit set and these columns have 0th bit n set. So we need to also make these different. So what we can do? We will set first bit to all of these integers. Okay, so let's say we will start from 30th bit. Okay, we will use 0 to 30 bit for rows and 30 to 63 for columns. Okay, so initially we have set 30th bit to odd columns, then we are able to make odd columns distinct from even columns. Now we would also like to make these columns distinct, so what we can do is we will set 31st bit to half of this 1 5 9, likewise this, and 3, and this. So we have divided into two equal halves, so these two are also distinct. Similarly we can do same thing in these columns also. Okay, so these two will be divided. So we will do this thing, we will keep on dividing these columns into half and half until this size of each set is equals to this size is equals to 1. So finally, after using this construction, we are able to make all of these integers distinct. So let us see its code also. The same thing I have implemented in this code. Initially I will have this vector a, initially 0 are filled everywhere. Now I will apply this operation on rows. I will start from 0th bit. I have taken vector v as my set of all rows. Initially all rows are same, so I would like to make all of the rows distinct. So I have called this recursive function frows. This recursive function, what it is doing, if the size of set is less than, if the size of this vector v is less than 2, then I will return. I do not need to do anything. Otherwise I will divide this vector v into exactly two halves. I will take all of the odd position, all of the elements of this vector v at odd position in v1, and all of the elements at even position in v2, and I will set this bit in all of the elements of v2. Now by doing this I am able to make v1 distinct from v2. Okay, because all of the elements have btth bit unset in v1, but this bt bit is set in all of the elements of v2. And then again I will call this recursive function for both v1 and v2, and I will pass next bit for this operation. Okay, similar I will do for columns also. I will store all of the columns in this vector v. By here what I am saying is I have all of these integers equal in each row for all of the columns. So I would like to make all of these integers distinct. So I am again calling this recursive function. Here I will divide, similar to this rows, I will divide this vector v into two equal halves. I will store all of the odd position in v1 and even position in v2, and I will set the btth bit in all of the elements of v2, and then again call this recursive function. So doing this I am able to make all of the elements distinct. So this was my solution. I hope you got it. Thank you.